let's talk about what we're going to be doing today. And hopefully Helena will join us soon. But otherwise, let's begin. So today we are going to be continuing with simplifying our trig identities, or trig expressions is what I should call them. So this is day 8, and we are simplifying our trig expressions. And this is part 2. Okay, and the first big thing is we just need to remember this big box right here, okay, that we talked about last time. And let's just take a look at it one more time. This is our reciprocal identities. We call this sine. Sine is 1 over cosecant. This is cosine. It's also equal to, oh, that says 1 over sine, but I'm sorry. That's supposed to say 1 over secant. This is tangent, and that's equal to 1 over cotangent. Tangent is also equal to sine divided by cosine. Cotangent is also equal to cosine divided by sine, and these are quotient identities. The last set of identities that we learned is called our Pythagorean identities, and it's these 3 right here. The first one is the biggest one. You got to know this one. Sine squared plus cosine squared equals positive 1. And we can rearrange this by moving sine or cosine to the other side to get these 2 sub-equations, where we say that sine squared is equal to 1 minus cosine squared. Cosine squared is equal to 1 minus sine squared. And that's it. Then we found out that our second identity is 1 plus cotangent equals cosecant squared. And of course, we can rearrange that to have our other 2 identities. And the same thing with number 3. This one just has tangent. And our big tips are going to be this. Step 1, make everything into sine and cosine if you can, or tangents, right? If you have a sine divided by cosine, that's a tangent. And we do this, so basically we're using our reciprocal identities. We want to get rid of cosecants and secants and cotangents. We want to get rid of those and turn them into sine and cosine. Then step 2 is to ask yourself, do you see any identities? And when I say identities, I mean Pythagorean identities. Do you see the number 1, a plus or a minus, and one of our trig expressions squared? This could also be the trig expression plus or minus 1. The 1 could be on either side. If that's a yes, it doesn't mean that it's going to be one of these, but you have to check and you look through each one of these and find which one will replace it. If you can't do that, step number 3 is if we have 2 fractions, let's say we have a tangent of x over secant squared, and we're adding that to 1 over secant squared, we want to combine these into one fraction. So this is the same thing as tangent squared plus 1 all over secant x squared. You could also say, let's say maybe this was actually a cosecant. Well, now we need to make the denominators the same. And we would do that just by multiplying this top over here by cosecant squared, and this 1 by secant squared. And now the bottom has. So all I did, it's the same thing as if I had maybe like 2/4 plus 3/8, or maybe 3/7. How do I add these together? Well, you multiply, we cross multiply. The 2 times the 7 gives me 14 over 28, because we do 4 times 7, plus 3 times 4, which is 12, all over 28. And now the denominators are the same. Can everyone give me a thumbs up? Masha, you said you remember how to do this, and does this make sense how we're doing it with our trig functions? Okay, awesome. So those are kind of the big tips that we have to remember. And everything else in this section is really just getting really good at pattern matching, remembering which one of these to replace, which one of these, remembering to combine fractions. And let's start to see that. Let's work on some examples. And that's what we're going to be doing today for the most part. So our first example, we have cosecant of x times secant of x minus tangent of x. And all right, let me ask Isa, can you tell me what is the first thing we can do? What is our first thing we're going to do here?
Hmm,
I think you're muted. Say that one more time.
okay. Is it to make cosecant into undo it?
Yeah, what can we make this into? What's it equal to? It's one of our identities. So take a look at our little cheat sheet. Which identity would it be? I think I'm not sure if you guys printed it out, but there was a sheet that says to print out. And if you want to refer to that, it says trig identities. All right, I think Helena has just joined. Hey Helena, can you hear me?
Yeah, I can hear you.
We just went over everything from last time. We just reviewed this big box I talked about. That's everything you're going to need for today. Today, we're just going to start working on a little more complicated problems with our trig functions. So Isa, can you say that one more time? Let's take a look at, this is our big cheat sheet right here. There was also one of these that you guys were able to print out if you wanted to. It says I believe 5.1
Is it
not factoring, sorry, trig ID formulas. You can refer to that if you printed it out. You can use that to figure out what.
is it one of
Mhm. So cosecant is going to be 1 over. Say it one more time, Isa. I'm sorry, you cut out.
sine?
Sine, perfect. And I like to remember this as the C and the S are opposite. Same thing with this one. So what do you think this one is going to be, Isa? Isa.
Is it one over cos?
Cosine, yeah. And then last one, what do we know about tangent? Remember, we want to make everything, the goal step one is make everything into sine and cosine if we can.
Sine over cosine.
Yep, sine of x over cosine of x. Perfect. And now here's the new thing that we were talking about. This is going to be step 3. So first what I'm going to do is I'm just going to multiply these together because that's what it says to do. So that's sine of x times cosine of x minus sine of x over cosine of x. And guess what? I don't really see anything I can do yet. For step 1 or step 2. But step 3 tells me, well, guess what? I have this fraction and this fraction, but there's a problem. Can somebody tell me what is the problem with these two fractions? I can't just subtract them. Why can't I? What do I need to do? Maybe Masha?
Is it because they don't have the same denominators?
Exactly. This denominator is sine times cosine, and this one just has a cosine. So what do we have to do to make them have the same denominator?
Would you have to change the sign to cosecant?
Not change it to cosecant. What we're going to do is we see that on the bottom here, it's sine times cosine. Well, what are we missing right here? We're just missing a sine. And if I want to put a sign down here, I have to also put a sign up here. So I multiply the top and the bottom by sine. And now the denominators are the same, right? So that's all we're going to do. We're going to multiply just this side by sine over sine. And I get 1 over sine of x cosine of x minus sine squared of x. These become squared all over. Well, this is the same thing, sine of x cosine of x. And guess what? Because these are the same now, I can put everything in one fraction. This is sine 1 minus sine squared of x all over sine of x and cosine of x. Helena, can you maybe tell me if you remember from last time? So step 1, or the first thing we're going to try and do is turn everything into sine and cosine. Once we do that, we're going to see if there's any identities. And when I say identities, I mean these ones are Pythagorean identities. If you see the number 1 and a plus or a minus, a cosine squared, a sine squared, a cotangent, a cosecant, any of those is a hint that we have to look at this chart. Okay. And if you see that, then we're going to replace it. So for example, if I see this, I'm going to replace it with this.
we always want to replace it with the simpler thing. That's what it means to simplify. If we only have this, well, then there's no reason to replace it with that. Same thing for this. If we see this plus this, that's equal to 1. And same thing with like this minus this, that's equal to 1. And those are ways we can replace those with simpler ones. If for some reason we can't do that step, then we do what we just did, which is the fraction step. We make these two fractions into one fraction. So after we've done this, Helena, can you maybe take a hint or a guess? What are we going to do here? Do you recognize anything we can replace or simplify?
We could use the first identity and we could change the 1 minus sine into cosine squared.
Perfect. Yep, that's cosine squared. And on the bottom is sine of x, cosine of x. So then, Helena, what does something cancel out? Can I make this simpler now?
Yeah, the cosine, I think.
Yeah, cosine down here and just one of the two cosines up here. So now that's equal to cosine on top and sine on bottom. And what is this equal to? Is that something that we know?
Cotangent?
Exactly. Cotangent of x. And guess what? If you've reached one function, you are the simplest you can go. Sometimes it won't just be one function. So you might be stuck somewhere else, and that's okay. But if you hit one function, you know you are good. That is the simplest you can go. Any questions on this guy? All right, let's take a look at another similar example. Let's do cosecant of x. Oops, let me write that the right way. Cosecant of x minus cosine of x times cotangent of x. And Masha, can you maybe tell me what would be our first step here?
You can turn cosecant of x
Mhm.
into 1 over sine of x.
Perfect. And what else?
Cotangent could be 1 over tangent x.
Yeah, but remember, we want to turn everything, if we can, into sine and cosine. Is there another thing that this could
Oh
become?
yeah, cosine x over sine of x.
Perfect. Yep. And we'll rewrite our function now, or our expression, I mean. So we have 1 over sine minus cosine times cosine all over sine. And then we'll just combine some stuff. We have 1 over sine of x minus cosine squared of x all over sine of x. And then maybe Isa, can you tell me what would I do next? What do you think I should do next here?
Would you combined it?
Yeah, we would take these two fractions and make them one fraction because the denominators are already the same. But if they were different, we would make them the same. All right, so that's 1 minus cosine squared of x all over sine of x. And what does that become? Maybe Helena, can you tell me what does this become?
Is it sine squared over sine?
Over just sine of x. Yeah, this is our Pythagorean identity, right? Squared x equals 1. That's our Pythagorean identity. And I would like you guys to get in the habit of doing something where you make a little note that says that this is a Pythagorean identity. And you make a little note of what you used. So we use this one. Because when you start to do this in a class, most teachers want you to explain how you know that this is this. And you do that by just making a little note that it's the Pythagorean identity and it's this one. So try and start doing that when you do your homeworks. And then, of course, well, look, there's one up there and one down there. So this is just sine of x. Any questions on this so far? Helena, any questions?
Nope.
Isa, did this make sense? Give me a little thumbs up. Perfect. All right, let's do another example. So this one I've explained this a couple times, but I'll show it again. So we have tangent of x plus sine of x times secant of x divided by cosecant of x times tangent of x. And anytime you have these fractions, I think the easiest thing, and I would always do this, and you should, there's no reason not to, is to turn it into multiplication. So I take my numerator and I rewrite this as being multiplied by 1 over my denominator. And this will make it a little easier for when we do, when we start to try and cancel things out. So that's step one. I always like to rewrite division as multiplication of reciprocal. Does anyone have any questions on that? Does that make sense? So anytime you have a fraction, like a big messy fraction like this, take the numerator and multiply it by 1 over the denominator. They mean the exact same thing, but it'll make it easier for us to see when we start to replace things, what cancels out. It'll be easier to see what cancels out. All right, so now let's ask maybe Helena, what could I replace here? What things can I replace? Can I change?
Maybe the cosecant.
For sure do the cosecant. And remember, we want to make everything that's not sine and cosine, if we can, into sine and cosine. So what does the cosecant become?
1 over sine.
1 over sine, perfect. And what else can we replace?
The tangent.
Yeah, we can replace both of them. What does tangent become?
Sine over cosine.
Exactly, sine over cosine. Same thing here, sine over cosine. Is there anything else that's not a sine or a cosine that we could replace?
Secant.
Yep, and what does that become?
1 over cosine.
Exactly, 1 over cosine. All right, so let's rewrite stuff. The tangent becomes sine of x over cosine of x. We're going to plus sine of x times 1 over cosine of x times 1 over sine of x times sine of x over cosine of x. And all right, I have kind of a messy fraction here, which we'll fix in a second. But look at this right here. We have sine of x over cosine of x. And this guy, I'm just going to put on top. That's also sine of x over cosine of x. And this whole thing is being multiplied by, well, this and that cancels out. So it's just 1. So this becomes, I'll rewrite it right here. This thing becomes 1 over cosine of x. But I'm not going to write it like that because it's kind of messy. I'm just going to write it with the cosine, right? This is the same thing as 1 times cosine of x over 1, which is just cosine of x. Did everyone see that? Did this make sense how I turned that fraction just by using this rule right here, that I can rewrite all division as multiplication of the reciprocal? Can everyone give me a thumbs up if that made sense? If it did not make sense, ask me. I can explain it a little bit better. Helena, did that kind of make sense how that worked?
Yeah.
Okay. So from here, what do we see about this guy right here? It's this plus this. Well, guess what? That's the same thing as sine of x plus sine of x all over cosine of x times cosine of x. And all right, well, I see a couple things. And maybe Isa, can you tell me what can I do now? What do you see I can do? What things can be combined or canceled or changed?
Can the both cosines cancel out?
Yeah, so we'll cancel both cosines out. And what do I do with this up here? What happens when I take one thing and I add it to itself?
It is it 2?
Yeah, 2 sine of x. It's like saying x plus x. That's just 2x. So 2 sine of x, and that's it, because we canceled out the cosines. Any questions on this? Can I get a thumbs up? Does this make sense, Helena?
Yeah.
Okay, awesome. All right, let's do one more example together. Hold on, I'll leave this up for a second for you guys to copy down. I'll grab our next example. So it's secant squared of x all over cotangent squared of x plus 1. All right. So let's do this now. And this one's a little tricky. Mostly because I realized the way I explain this is, like I said, these are tips. They're not exactly what you're supposed to do. So not every time are you supposed to do this first. Not every time are you supposed to do this second. Sometimes you are. And the best rule of thumb is almost always you want to replace everything with sine and cosine. But do we notice something right away? Do we see an identity here that might be easier to replace? And sorry, before we do that, the very first step is I'm going to rewrite this as multiplication of the reciprocal because it makes it a little bit easier. But after I do that, does anybody see here? Is there an identity that we know? Maybe Masha? Is there an identity that we can use from our little toolbox, our little cheat sheet we made that I can replace some things here?
Yeah, that would be like the second one.
Which part would be the second one? And I'm sorry, I wrote cosine versus cotangent.
Oh, yeah, that would be 1 plus cotangent squared of theta equals cosecant squared of theta.
Exactly. Equals cosecant of x. And even if the one, right, the one is on the other side like it is here, it means the same thing. So that's perfect. We're going to replace this with cosecant of x. So now I have, if I write this, I have secant squared of x times 1 over cosecant. And I'm sorry, this is squared. This is squared. This is squared of x. All right, and then maybe Isa. Now what can I do? Basically, every time you do a step, you go back to your list of tips and you go through each of them and ask, what can I do? Can I replace everything in sine and cosine? Is there an identity? Is it fraction? What do we see here?
Do you make everything into cosine?
Yeah, so what would secant become?
Equals to 1 over cosine.
Yeah, but just remember that squared, so it's 1 over cosine squared. And what about 1 over cosecant? What does that become?
Is it 1 over sine?
It is 1 over sine, but is that the same thing as just sine?
Oh yeah.
Yeah, and remember squared. Why? Well, guess what? Sine of x is equal to 1 over cosecant of x. So if you see 1 over, that's just sine. You don't need to add the extra 1 over. And remembering it's squared. So we have 1 over cosine squared times sine squared. Helena, what do you notice next I could do?
When you put the sine on top of the cosine, it turns into tangent.
Yeah, but not just tangent. What do we see about the sine
Oh,
and cosine?
squared.
Exactly. That's just tangent of x squared. And that's it. That's it. We've got one whole fraction, so we're good. Any questions? All right, let's try this now. We're going to do a practice one. So I want you three to do this, and I'll give you 5-ish minutes. Or let's do maybe 3 minutes. This one I think is kind of short. And then I will do it together. So we have on top 1 minus sine squared all over cosecant squared minus 1. All right. I'll give you guys some time, work on this one, and then when we're done, we'll go through it together. And let me know if you have any questions. Sorry about that. Let me get the screen just disconnected. Let's get that back up.
Right. Let's do one more minute. All right. Don't worry if you're not done. Let's go through this together. Let's maybe start. Helena, can you tell me what am I gonna do first? What do we recognize we could do first here?
Um, I like separated the numerator and denominator. I did 1
Mhm.
minus sine squared x times 1 over cosecant squared minus 1.
Yep. And that's a perfect first step. I would do that too. You don't have to though. If you I see Masha did it a slightly different way. You separated the fraction after. That's perfectly okay. Whatever works for you. Helena, can you tell me then what do we do next? What do we notice we could do next then?
I knew that the 1 minus sine was cosine squared x.
Exactly. And what do we notice about this guy?
Um,
Maybe down here.
I didn't really know how to do that one.
That's okay. Does it look kind of similar to this guy? It has the number one, and it's being subtracted from a trig function squared. This is just cosecant. So can we take a look at let's go together. Let's look at our little cheat sheet we made. And do you see one of these that maybe matches that?
The cotangent one
Yeah,
is like,
exactly. Cotangent squared. So just like you did with this one, we just have a different one to memorize, and this one is cotangent squared of x. So we're going to rewrite this now. That's cosine squared of x times 1 over cotangent squared of x. And then maybe Isa, what would I do next here? Can we replace, so this is in cosine. Can we replace other things? What can we do next?
Change it into
What are we
cosine
going to change?
over sine.
This one, yeah, we could change this. There's a couple ways we could do this. We could say that this is 1 over cosine of x over sine of x. That's perfectly okay. And then we would just say that, well, that's the same thing as 1 times the reciprocal. But another thing you can notice is guess what? What is 1 over cotangent? That's just tangent squared of x, which is sine of x over cosine of x. And I'm sorry, there's squares in there. Does that make sense? So both ways work. They mean the same thing, but whatever is easier for you. So just realizing that 1 over cotangent squared of x is equal to tangent. So we get a cosine squared of x times a sine squared of x all over a cosine squared of x. And our very last step, That and that cancel out. Any other questions? So our final answer is sine squared x. Any questions on this? Elena, does this make sense?
Yeah, it makes sense.
Masha, were you able to follow? Does that make sense? Awesome. Isa, does that make sense as well? Do you have any questions?
No, it made sense.
Awesome. Let's do some more examples then. Let's do this. Yeah, this example. We have cotangent of x minus cosecant squared of x times cotangent of x. All right, we're going to learn about a new tip. This is my new number one tip. Okay, so this is new tip number one. It's going to replace our new number one tip. You're always going to do this first. Factor. Every time we're going to factor. And I'm going to make some quick notes. There's a couple different types of factoring. The first type is what we call the common factor. And this is the perfect example. Look at our common factor. We have a cotangent of x minus this times another cotangent of x. Anytime we are adding a bunch of things, for example, like let's say ax plus bx plus c squared x, guess what? All of these share an x. So we will factor out the x. So that would be a plus b plus c squared. And guess what? X will most likely be a trig function. So x might be cosine of x or sine of x or tangent of x, etc. That's the first type of factoring. Okay, so anytime we see that, that's the very first thing we're going to do now. And I'll do that first example here. We're going to factor out a cotangent. And what does that leave us with? Can somebody tell me, what do we remember from factoring? Anybody want to take a guess and tell me what does this become when I factor out a cotangent?
Is it 1 minus cosecant squared of x?
Yep, exactly. That's it. And maybe, Masha, what do you think we would do next? Now that we factored this out, what do we see?
1 minus cosecant squared would be cotangent squared of x.
Not exactly. Let's take a look. What is the identity? You're on the right track, but what is the identity that cosecant comes from? So this is why when I told you anytime you see this, we're going to write down the identity. So let's write it down. What's the one that you actually see that we have written down? It's the 1 plus what? Cotangent squared x. What does that equal?
Cosecant squared.
Cosecant squared of x. All right, so let's see something. Cotangent squared of x, well, that's equal to cosecant squared of x minus 1. But that's not what we have here. We have 1 minus. So anytime you rewrite, I always like to rewrite the Pythagorean identity I'm using and then compare it. This is a positive cosecant and a negative 1. This is a positive 1 and a negative cosecant. But guess what? What happens if I multiply both sides of this by negative 1? Well, this side becomes negative cotangent squared of x. And this side becomes, well, this becomes a minus. So that's minus cosecant squared of x. And this becomes a plus 1. And we can move the 1 to the front. And that's the same thing as cotangent squared of x equals 1 minus cosecant squared of x. So this isn't cotangent. What is it actually? What does it say right there? Maybe Masha.
Negative cotangent squared of x.
Exactly. So I'm going to copy our tips back over here, and we're going to edit these tips a little bit. So our tips still apply, but now we're going to move some things. We have a new number 1. Oops, there's our number 2. Here's our number 3. And our new number 1 is factor. Okay? But we're going to put a little side note wait, sorry. 1, 2, 3, and this guy is 4 now. But we're going to put a little side note on number 3. We need to make sure that it's, or let's maybe just say, make a side note that says our identity might be negative. Okay, so all that means is anytime you see this one, all right, it's a cosecant. I'm gonna look for the one I have written down with cosecant, rearrange it, and if this is not matching that, this one's positive, this one's negative, this one's negative, this one's positive, then I'm gonna flip it and I'm gonna make sure that I write negative cotangent. Does anyone have any questions on that? So that's the big thing to remember. So we learned 2 new tips, factoring and making sure that we know if we have a negative Pythagorean identity. Does anyone have any questions on this? Helena, does that make sense?
Yeah, makes sense.
Awesome. All right. I'm going to briefly mention this because this problem doesn't need it yet, but there's actually a second type of factoring, and this is called the difference of squares. Anytime you see an a squared minus a b squared, that's equal to a plus b times a minus b. And a and b are, when I say a and b, it's most likely going to be either a sine squared, a cosine squared, a tangent squared, any, etc., or maybe a 1, and that's a or b. Okay, both of those will be some kind of trig. All right, so those are the 2 types of factoring that we're looking for. And then, yeah, let's continue this. So we know that this is cotangent of x times negative cotangent squared of x. And our final answer, that's just negative cotangent cubed of x. Okay? Any questions there? Give me a thumbs up if that makes sense. Helena, do you have any questions on that one?
No, makes sense.
Awesome. Let's now do another example. This one is going to be cosine of x over secant of x plus 1 plus cosine of x over secant of x minus 1. And maybe Masha, can you tell me what do you think I should do first? What should we do first here?
Should we use like the identities for the bottom first?
Do we see an identity here? So what do we notice about this? Is this, remember, what do we need for identity? Say it one more time.
They're not squared, so
No, so we can't use our identity, but anytime you have a fraction, 2 fractions being added or subtracted, what's that a hint that we should do?
can we factor it?
We could factor, but it might, there depends on what you're saying to factor. There's nothing wrong with that step, but it won't help us. It won't hurt us either. You can do it that way. Out of curiosity, what are you thinking of factoring? What would you factor out?
Or maybe we could just turn secant into like sine, or
We could do that, but there's this pesky plus 1 here. What do we know we're going to do when we have 2 fractions? What's our tip say to do about fractions?
make them have the same denominator.
So remember, the order of these tips is not absolute. There's nothing wrong with factoring. In fact, you can always do factoring first. And the only thing I would say to factor is maybe cosine. The reason is because that won't affect the answer. You'll take cosine and then you'll just have 1 over that fraction plus 1 over that fraction. There's nothing wrong with that, but we still need to deal with the fractions. So there's nothing wrong with factoring as the first step, but these are more of a suggestion, not an absolute. And anytime you see an obvious trig identity, replace it. Anytime you see an obvious fraction, deal with the fractions. And what do I mean by deal with the fractions? What are we supposed to do with these guys? We want them to be what?
Be the same.
Yeah. So to make sure they're the same, if they're not the same and there's not like, I can't just do something to one to make it look like the other, I have to cross multiply. I take this one and multiply this guy by the top and bottom. So this becomes, I'm going to make some space here so I can write it. We're going to take this guy and multiply him by secant of x minus 1 over secant of x minus 1, right? So that these denominators are the same. And we'll do the same thing over here, but with this guy. We'll multiply the top by secant of x plus 1 all over secant of x plus 1. And now, so let's rewrite what that becomes. That's cosine of x times secant of x minus 1 plus cosine of x times secant of x plus 1. And it's all over one fraction now. Secant of x plus 1 times secant of x minus 1. And here's the big hint. I talked about it right here, but this is something we have to recognize. Anytime we see an a plus b times a minus b, that equals a difference of squares. A squared minus b squared. That's my difference of squares factoring. Instead of it being this and you make it look like that, we're starting with this and we're going to make it look like that. From this hint right here, Helena, can you tell me how I can use this fact to fix the bottom? What am I going to make that?
Um,
So the top
we
stays the same. And what does the bottom become?
does it become secant squared
Of x.
of x and is b would b also be the same thing, but like a negative?
Negative what? Say it one more time.
Negative
So
secant.
not secant. So look,
Oh,
this, we see a. You identified secant is a. So there's my a squared. What is b? What's going to be the minus b squared? So here's the a
oh,
squared.
1.
Yeah, 1 squared, which is just 1. Does that make sense? So what did I do here? I see that this is something plus something times the same something minus the same something. That's this right here. So everyone give me a thumbs up. Helena, does that make sense? That anytime you see this, that's a difference of squares, and that is part of our factoring step, and we have to recognize that. Any
Yeah, makes
questions?
sense.
Perfect. Well, does anyone see why we did that? Is there maybe something that helps us do?
It's an identity.
Yeah, what's that identity? So I'll keep the top the same for a second. And what does that identity become?
Tangent squared of theta, or of x.
Yeah, so let's write down what that identity says. So that identity says that tangent squared of x plus 1 equals secant squared of x. So tangent squared of x must equal secant squared of x minus 1. And there's no weird negative trick because this is exactly that. So perfect. Tangent squared of x. All right, we dealt with the bottom. Now let's figure out what's going on with this messy numerator. Do we see anything we can factor out, change? What do we see we can do? Anything that we notice we could factor out or change? Maybe Isa, do you see something we can factor out or change? Also, let me know if I'm going too fast. I can slow down. Isa, does this kind of, we caught up? Does this make sense?
Yeah.
Okay, awesome. Do you mind, what do you think we can factor out up here?
The two cosine.
Yeah, so I'll factor out a cosine. And what am I left with? What does this term become? What's
Um,
left? Just what?
cos
What's
2,
that guy called?
secant x minus 1.
Mm-hmm. And I'm gonna add that to what? What is this guy right
Uh,
here?
secant x plus 1.
Perfect. And we already know that that's all over tangent square root of x. All right, well, it's still messy, right? There's still a lot of stuff here, which usually means it's not simplified enough. What do we think we could simplify more of? Can we change anything? Do we see anything we can change? Well, let's go back to our tips. What maybe have we not tried yet? Maybe Masha, what do you think we should do next?
Um, should we try making the secant into 1 over cosine?
Yeah, let's try that. So we'll leave the cosine. We'll take this first secant, make it 1 over cosine minus 1, plus this other one is 1 over cosine plus 1, all over tangent squared of x. Masha, do you think, could you maybe take a guess? How can we start to cancel stuff out? What could we maybe do? We see there's cosines here and cosines here. What can we do? There's a math term. Um, I'll tell you it's the opposite of factoring, if you remember what that's called. But what can I do with this guy?
Distributing?
Yeah, exactly. This times that, and we'll do this times that. And we also have to do this times that one, and this times that one. So what does that top become? What's cosine of x times 1 over cosine of x?
1.
Yeah, they cancel out. So that's 1 minus, well, this guy times 1, this is cosine of x. Plus, well, this guy times that guy, well, that's just 1 again. And this guy times that guy, well, that's just cosine of x. All over tangent squared of x. All right, well, what cancels out up here? What do we see cancels out?
Negative cosine x and positive cosine x.
Yeah, and what are we left with? What happens when I combine these guys? What do I get on top?
2 over tangent squared of x.
Yep, and this is about as simple as it can go. If you want, you can also rewrite this. If anybody has a bonus, can anybody tell me what do you think we can also rewrite this as? 2 times what?
Cotangent squared of x.
Exactly. But both of these are simplified. Both would be an acceptable answer. Awesome. Any questions? So I know that was a lot. It's a lot of steps. That's what a lot of these problems kind of are. They're just really tricky, kind of manipulations. With that said, are there any questions before we go? I think we'll leave it here. I will do this though. And I'll give you the answer, but I want you guys to maybe try this example before you start your homework. So cosine 1 minus cosine x over tangent of x plus sine of x over 1 plus cosine of x. Try this one for homework, and this will be the first one we do next time we meet. And then for homework, the rest of your homework is on the table of contents, and it's going to be just continuing with the trig expressions. You're going to use that other worksheet you did for part 1 of the homework, and it's going to be numbers 22 through 35. So in your homework, you'll see 5-1, page 317. That's the file name. And you're going to do number 22 through 35. And if you feel like you want some extra work, try 38 through 47. So all of these. Any questions before we go? All right. Awesome work today. Isa, no questions. Helena, no questions.
No.
Awesome.